So what are the variables in the graph? We'll start there before we even go any further. And the variables are time as the independent variable and height, or really another way of thinking about it is elevation of the hiker. And I just want to really quickly say elevation means how far above sea level, right? If all the water in the world settles down to the same level, you're measuring from there, like how many feet or how many meters or whatever above that line around the Earth are you at any point on the Earth? So the graph shows, oh, so it also says, show how they are related at certain points in the graph. The graph shows a hiker, the height of a hiker above sea level. The hiker walks at a constant speed for the entire trip. This is a huge bit of this. The hiker walks at a constant speed for the entire trip. And I'm going to underline that because that means that the hiker is not stopping. Okay? That's going to play into stuff when we go. So what are the variables? Describe how the variables are related at various points on the graph. Okay, so the variables are height and time. That says that for all of them. For A, it says for the first part of the graph, the height increases slowly. That's this. And you can see that over the same amount of time. And they're walking at the same speed. That means that they're covering the same distance over time, right, over the same period of time. So if they don't go up by much, that means that even though they're moving quickly, the ground isn't rising much. So for the first part of the graph, the height increases slowly, which means the hiker is climbing a steep incline. That's actually not true. If they were moving at the same speed and it was going up like this, then it would really be a short distance to gain elevation instead of a long distance to gain elevation. And since they're covering the same amount of ground, whether it's steep or not, that would mean that they have a really short amount of distance to go to gain elevation, and therefore it should be happening more steeply. So I don't like it. So I'm going to put a line through that part, which I don't agree with. Okay. Flat parts show where the elevation does not change, which means the hiker has stopped to rest. Well, what do we know about the hiker? We know that the hiker is not stopping. Look under what I underlined in yellow at the top. Hiker hikes at a constant speed. So hiker stopped to rest? Nope. So already we know A isn't going to work. The steep part at the end of the graph shows that the hiker is descending a gentle slope. Well, if they were descending a gentle slope, then a gentle slope means there's not much elevation change over long distances. And if they're covering at the same speed, they wouldn't be changing their elevation much. So I also don't like that. That is not, a gentle slope would drop your elevation slowly, not quickly, like the steep slope of this part is. Okay? So I say A, no. Okay. Variables are height and time. For the first part of the graph, the height increases slowly, which means the hiker is walking up a gentle slope. That makes sense. The flat parts of the graph show where the elevation does not change, which means the trail is flat here. That does also make sense because they keep moving. So how do you keep moving but not gain elevation? Well, the ground must be flat. And by the way, this is worth saying at this point that a mountain doesn't look like this. Okay? A mountain looks like this as you go, right? Not maybe this part right here where it's so steep, although possible you'd probably go around that, but the idea is that it's uneven ground. Sometimes it goes up, sometimes it goes down, sometimes it's flat. And so, you know, if you see as a mountain as just you've never hiked a mountain, you see it just straight up to the top without any kind of change, then that's not actually how it works. Okay, so let's keep going. Hike up a gentle slope, flat parts show where the trail is flat. The steep part at the end of the graph shows that the hiker is descending a steep incline. Yeah, that's what I had said earlier. So I like B. I like B. I'm going to circle that, and let's come back to it in a second. Okay. The variables are height and time. Yes, for the first part of the graph increases slowly, which means the hiker is climbing up a steep incline. Again, steep inclines, if you're moving at a constant speed, steep inclines will change your elevation quickly. Okay, so changing it slowly like this is not accurate. Flat parts of the graph show where the elevation does not change, which means the trail is flat here. That's good. The steep incline at the end shows the hiker is descending a steep incline. I agree. Okay, it's just that here, if this is what it looks like to descend a steep incline, and you're always moving at the same speed, then you should be moving up it with the same rate, and so it should be also steep like that. It's not, so it's got to be gentle, and that's what this says. The hiker is walking up a gentle slope. D says all of the above, but they couldn't possibly be all of the above because they contradict each other. Okay, so it's not C, it's not A, not D, it is B.